कुछ नहीं है. Okay. So let's do this. We'll try and because I got a message from quite a few people, they're not. I mean, at least 2-3 people told me they're not joining. Okay, so let's first import the libraries. Main two libraries, pandas and numpy. What? Okay, sorry, my screen is not visible. Sorry, one second.
Yes, so your screen is not.
Is it visible now?
Yes, yes.
Okay. So we'll import the libraries first. So import pandas, import matplotlib. Okay. I've copied everything over here, by the way. Import matplotlib. So we look at the real estate data set. So I have copied that real estate data set in this folder. Is that? This is the file. Let's read this file. How do you read a file? I'm assuming you know that. How to read the file? Data set dot head to see the data. So these are all my data elements. 1, 2, 3, 4, 5, 6, 7. I have to predict the house price. I am going to predict the house price for using all the other elements which are there. So first of all, we should check what is the, one second, let me just save this. Check whether it is null. So there is a function to check null and we'll do sum of that. So for each of those data elements which are there in the data frame, it will tell you whether there are null values. So there are no null values or there is no missing element over here. So that is good for us. We don't have to do anything in the data. Ideally, if you would have done this in Excel, you would have had to filter each column or do something dramatic to find that out easily. Actually, you can do a pivot table. So that will give you that answer. So the first step, I want specific values. In the sense, I just want in my X, I want only 1, 2, 3. So this is 0, 1,
Sir,
2. Yeah.
sir, if we had missing values, I read it that if it is below 5%, we can drop it, and if it is more than 5%, we can drop the whole. We can ignore it, but if it is more than 5%, we can drop the whole column or the whole row. Sorry.
Yeah, we'll see that there is one more file which I'll show you that will have values. Ideally, average of that, I'll show that to you. The
Okay, sir.
prostate data set, right? There is average. You have to do an average. If you remember, we had done that earlier, but I'll show that to you. How to do it.
Okay, sir.
So now you have this. We have to find out X. So X is equal to data set. I do this, comma this. I don't need the last column. Okay, so I can remove the last column. I do -1. I forgot, right? I lock. And if I do x dot head, I get values like this. Okay, I can see the values properly. I don't need this column also. This first column I don't need. So I'll start from 1. So now the first column is also dropped. So I don't have that number because it doesn't make sense. Okay, I'll make this dot values. And now I print it. There is no head because it is not a data frame. It is an array. So this becomes like an array. The second value which we want is the last column. So y should be equal to data set dot ilog colon comma -1. And if I print y, so I get this. I need to convert it into an array, so I make it values. So I have another array of this. Now I need a regressor on any model. So I have to import sklearn dot linear model from import linear regression. Okay, I have to import this. And once I do that, I will put regressor equal to linear regression. I have done this. I imported linear regression. The next step, regressor dot fit x comma y. I'm not splitting the data, but we can split the data. We'll use that also and check. So I fit the model regressor dot core x comma y. So the asker value is 0.583. Okay. If I see regressor dot coefficient, I get the coefficients for each of these parameters that I have. Okay, for all of these transaction date, house, everything. So I've been able to fit the model. If I now say y prediction is equal to regressor dot predict, I say x. I can now compare both of them using a plot. I want to type everything again. So I have this. I'm going to plot. Yeah. So here I have how many columns? So let's see what is the length of y. There are 4 values. X. Either x. Here x. This is the question you're asking.
Yes, sir. So why are we, sir? You have written y pred is equal to regressor dot predict x. That why x, why not y? Because I have taken it as y, and
Predicting.
it's saying to reshape the array.
No. You have to predict the value of y using x. The formula y is equal to ax plus b. Y is equal to
Oh,
mx plus
oh,
bx.
yes, sir. Yes. Okay, sir. Okay, understood. Yes, sir.
So this is my length. I have 400 values. I cannot, if I plot 400 values, it's not, I'm not sure how good a plot it will look like, but let's see. Okay, so I'll plot from 1 to 414 and plot y. And same 1 comma 4414 and I'll do y pred. it plot. One second. I have my tablet. X and Y must be of the same size. And Y. Forget this. X and Y must be the same. Int Y. And the Y is 4 on 4. Very good. Now I'm getting it. What did I do? Okay, I have to blood in here. So if I draw it like this, it doesn't really give me a good sense because the data, there's a lot of data and this plot is very small. So let's plot for 20 values. And here I will put 20 values. I might get an error. Whoa. Practically, this is telling me how the predicted value, the blue line is the predicted value and the green line is the actual value. So that is how the prediction is coming for that multiple linear regression. You can't visualize a plot with more than 4 to 5 values. That is why you're getting an error. I mean, that is why it shows in this way. Now, the other aspect which you need to do is you need to split the data. In order to split the data, like I had mentioned, we should ideally, so if I take this, whatever that size, I am splitting the data using X and Y. So I get X train, X test, Y train, Y test, and it is split as 20%. Okay, the entire data set is split into 20% and 80%, where my training size is 80% and my test size is 20%. Now what I can do, I can create another regressor, which is train is equal to linear regression. Linear regression. Okay. And this regression, for this regression model, what I will do is I will use X train, comma, Y train. Okay, I use this to fit this. If I check the score, the R square value, I get 56%. There isn't much of a difference. And now if I predict the values, I can predict for using this model, I will predict the test scores. So I get this Y predict test. In the same way, now what I can do, I can compare my, if I check the length of Y prediction, 83 values. So let's try and plot those 83. I don't know how good it will look. I don't think it will look that great. Okay. And what I'm going to use, Y pred test. Yeah. This should be Y test. Okay. So I'm using this model and I am predicting for those points. Does it make sense? I create a model using training data and I predict it for the test data. I can still compare both of them. So you understood this one, the real estate data. Arpita, you had doubts on this one, right? Hello?
Hello, sir. Sir, understood.
All right.
Uh, sir,
Yeah.
so some work has come up. I will have to leave, and I'll be back in half an hour.
Okay. All righty. Now let's look at another data set which was there that might, what else, what other data had given you? What is this? Fish, the fish data set. So let's try this also. Fish, fish, fish. So let's again read the fish data set. And we'll check the data again. Okay, so this is my data. So in this fish data set, what do we have to do is, let's see what we had to do. Yeah, you have to predict the value weight of the fish. So I'll read this I have read this data. I have to predict this value. Okay. My species, if I open this data, let's open that data once, which I have. One. Now, this has so many different values. Bream, Parky, Perch, Pike, Roach. These are all the fish. So we need to convert these values into categorical variables. So we have not seen how you do that in Python. We'll see that now. How do we convert this into Python? In Python, how can we convert this into categorical variables? You might have done it manually in Excel, but we'll see how we can do that in Python. Let's see that. That's it. This is it. I'm going to use. I'm going to show you how it is done in Python. This is basically the code for that. What I'm going to do is take this value. If I have to do it in Excel, let's say we have to do this in Excel. Okay. Let's say I take this column, I remove the duplicates, data, remove duplicates, 8 values removed. So I have these different values. So what do I do? I will take each column. I'm going to transpose this by each of these values. And what will I do now? Wherever there is bream, it will become 0, 1, 0, 0, 0, 0, 0, 0. Wherever there is the next one, party will become 1. I'm doing this manually in Excel. Wherever there is the next perch.
Sir,
Yes.
sir, in this I just wanted to ask what shortcut did you apply since there are only 5 ones, so rest आपने वो 0 0 कर दिया तो कैसे किया कौन सा शॉर्टकट यूज किया
कंट्रोल डी ये
कंट्रोल
नीचे वाले
हाँ नहीं सर वो वन खाली सिर्फ 5 6 ही थे ना तो बाकी आपने ऑटोमेटिकली वो 0 और 1 कर दिया तो कैसे किया
अभी ऐसा है तो मैंने इधर 0 0 0 0 0 इधर 1 डाला इधर इधर 0 डाला आप बोले नीचे
हाँ
वाले
हाँ अभी बाकी सब भी आप वो कैसे कर देते हो
कंट्रोल डी करने का रहता है
कंट्रोल डी
हाँ सिलेक्ट द रेंज एंड डू कंट्रोल डी
अच्छा ओके ओके
भूल गए
हाँ सर वो थोड़ा भूल गया
व्हेन यू स्टार्ट वर्किंग इन एन ऑर्गेनाइजेशन ऑटोमेटिकली आ जाएगा वो
ये सर एक्चुअली करंटली रेगुलर यूज नहीं करते तो भूल जाते हैं
So this is what we did in Excel. Right? This is what we have to do in Excel, wherein I take this data and I am creating my own model in this manner. I don't need one column because that is what we had understood earlier. The reason being one of them becomes redundant because even if I remove this one, I know, or rather if I take just this one, I know the other values are going to be 0. So I can easily remove one column, whatever column that I want, I can easily remove that. Over here, I can now use the Excel add-in. I go to regression, multiple linear regression, take the X value as all the columns, remove one. I did not take one of the last one, the species. I use fill. My Y is this weight. I use fill. So here column headings included data. I have used that. I do this as new and I click OK. So I get my regression values. I get R square as 0.936085. Okay. So hopefully we'll get that same value over there in terms of in Python as well. So the first step that we have to do is, that is the only step we need to do. We need to convert this first column species into a categorical. It's categorical variable, but we need to convert it into a dummy variable. So what we use these two libraries of sklearn. And if I search for sklearn, I search for sklearn, I get this sklearn. I go to this website, you get a lot of information related to this library. There are specific libraries in sklearn for classification, regression, clustering, for model selection, pre-processing. Quite a lot of them are there. You go to APIs. So if you want to search for anything, you can search for that. So here, if I search for linear regression, I see this linear regression model. So this is what we have done. Okay, when we write this import statement, and we have written this import statement over here, where is it gone? Yeah, we wrote this sklearn linear model import linear regression. We wrote that because of this. This is how the library is. Okay. So in that same way, we'll also look at logistic regression. How do you import the library of logistic regression? All right. So here I'm going to use these two libraries, column transformer. So let's say if I search for this, I get this column transformer. Okay, that is what I'm going to use. If you want to know more about this library, you can go here and understand if it makes sense to you. I am going to use column transformer and something called as one hot encoder. The column for which we want to encode the values. So this column is 0. So the 0th column, I want to encode the values. And I am going to do it for that. So first, before doing that, let me first split the data into X and Y. Let me split the data into X and Y. I'm just going to copy this and keep it here. In order to split the data into X and Y, what do I need? The weight is my Y column. Okay, the weight is my Y column. So I'll write fish X is equal to fish. Now, how do I do this? How do I do this? Okay, let's try this. Dialog. 1, 2, 3, 4, 5, 6. -6 if I do and see what happens. I'm getting only the first. Sorry. I have to do how do I do this? Very interesting. Okay. Is there an easier way? Yes, there is an easier way. Let's first make y. Okay, let's first make y. That is easier to do. Y is 2. So I have the weight of the fish I have in fish underscore y. Okay. So I'm going to add another cell above. In this fish underscore, now we want x. So what I'm going to do is, first of all, I'm going to copy this fish. Copy. And in this fish, C dot, let's say there is a drop. Okay, there is a drop word, and I'm going to drop the field weight. It is not in access. Why? How do you use drop? Second. We need to provide the access. Okay, access equal to what? Alrighty. Now if I do fish underscore C and head, I don't have that column. Very good. Okay. So I have this value and this is my X. I'm going to make this my X. X is equal to fish underscore C. And let's try this, the 0th column, if something happens over here. I am using this one hot encoder. It should give me an output that I want. Okay, now if I do X, you notice it has added these columns. It has added specific columns in the beginning. X dot headphone क्या चलेगा क्या? अरे है नहीं मिलेगा. So there are 159 rows and 12 columns. So what has happened when I look at my Excel sheet, which I had? Okay, I had this. I don't have weight. I have all these columns. I have these 13 columns. It has given me 12 columns in the end. All right, so I don't need to do anything else practically over here, hopefully. When I see this value, I have all these columns that I require. Do you understand what happened? Did you understand what happened? Using this one hot encoder, we have accomplished what we did over here manually. This zeroth column, if I print this x, 1, these are all the first rows of this column, of this data set. If I do 2, does it make sense what is happening over here? Notice 24, 26.3. So let's say over here 24. Where is 24? Notice this 24, 26.3, 31.2, 12.48, 4.3056. 4.3056. Yep, this is this row. And it has given me 1 0 0 0 0 0 0 like this. So let's look at where this species value is. What did I do wrong here? वैसे भी ये 0 है तो ये क्यों है? Okay. Second, now I am just checking one thing. This is actually I have one column extra. Okay. So let's look at the first value again. First row rather. So this is the first row because 0 has the array will give me the value of 0. 1 0 0 0 0 0 1 2 3 4 5 6 7. So how many do we have? 1 2 3 4 5 6 7. I have 7 columns like this. Okay. Then I have the value 23.2, 25.4, 30, 11.52 and 4.02. I see the same values which I have got encoded in my Excel sheet. Okay, this is the same value which I have got. You understood what has happened? I have done the same thing. I have achieved the same thing over here by using the step of one hot encoder. It was just that column was just a duplicate. It was actually of no use. I had copied this species column and pasted it over here. That is why that it was completely 0, by the way. There is no word species over here. I have all the 1 2 3 4 5 6 7. So there was a mistake which I had done in this. When I had just copied it, I kept that same column and I put that as 0. Understood? So practically I have these columns, all these columns which are there in my Python code. Right. So now I don't need the last column. I don't need one. I mean, I don't need one of these columns. Okay. I don't need one of these columns. So if I do X and Nothing is happening. One second. Huh? This is what I wanted. Yes. So I have removed the first column using this. I can assign this. Let's say I assign it to x1. Okay. X1 is this. I know my y is. I already have my y, fish y. I can keep this fish y. Physics. Fish. I have both of these values now, and I can now use another regressor. Dot fit. We'll use. I'm using the entire data. Like I said, we can again split that also. But for ease of comparison, I'm just using the entire data. It's coming 0.93608. So I had made a mistake because I added one additional column. Let's see if I can get the same value over here. Okay. I'm going to add another sheet. And I am going to copy this data. I'll remove this one. So that is also what I have not considered in my Python code. Data analysis, regression, multiple linear regression. This is my X, this is my Y. Fill, put a new, okay. 0.93608. Wow. Yep, we're getting the same value. If you want to check the coefficients, so you can check the coefficients. One 164, 137, 137. So we are getting the same coefficients as well. And if I check dot, we are taking the intercept minus 918. All right, so we have this. We are getting the same values in both Excel as well as in Python. Understood?
Yes, sir.
Okay. So I'm going to explain the concept of logistic regression, and we'll try just one value. one data for that. Okay, one data set for that. This. So this is linear regression. Yes, this is linear regression where the equation is y is equal to mx plus c, or whatever it is, b0 plus b1 x1, whatever you put it, where you have an intercept, you have a slope of the line, you have a dependent variable, you have an independent variable. Okay, that is how linear regression is, wherein you're trying to fit the value for in against a line. But sometimes, and this is where you're like predicting the salary based on the experience. But there can be a case where the value is like this, a yes or a no. That is a 1 or a 0 or a 2 or a 4 or a 3 or a 6. The value is that way. Okay. So what happens over here is I cannot use linear regression. Can you tell me why? Any idea why?
Points are parallel. Because we will get points on extremes.
Yes, points are extremes. That is why you can't use linear regression. It is a yes or a no. Over here, it was predicting salary, which is increasing with experience. Okay. So here, I have this line over here. Probability, this is like predicting probability. It is a yes or a no. Right. So if I even since the values are between 0 and 1, that is why you're predicting the probability. So what you do, if I draw a line like this, if I draw a straight line, even if I still go and use linear regression, my line will go like this. But we know that the probability cannot be more than 1, nor can the probability be negative. We need to cut this line from here and put it like this. So what you get is you get a S-shaped curve. You get a curve like this. Like I said, probability cannot be less than 0, probability cannot be greater than 1. What you get is an S-shaped curve. It is also called as a sigmoid curve in mathematics, statistics. So what you have a logistic regression like this. You have this equation in the sigmoid function. If I substitute this value of y is equal to b0 plus b1x and put it in this equation of the sigmoid function, I will get this. Okay, I will get this line, this equation, which is equal to same thing, b0 plus b1 x1. But on the left hand side, instead of y, I have this natural log of p upon 1 minus p. Okay, mathematically, this is how it is there. So what you get? You get the probability. You get this probability, which cannot be less than 0.
What this graph is showing?
Sorry?
Can you explain this curve what it's doing?
So like I said, you cannot use linear regression, because linear regression is a line which is like this: y is equal to b0 plus b1x. Logistic regression is when you have data, when you want what value you want to predict is either 1 or a 0. It is a labeled value, whether the person has cancer, does not have cancer, can get cancer or cannot get cancer. So mathematically, and I'm not going to explain the mathematics of this technically, but mathematically what you get is, like I said, right over here, my probability cannot be greater than 1, my probability cannot be less than 0. So I have to cut off this line over here. I have to cut off this line over here. So what I get is, I get a line like this. You understood till here?
Yes, sir.
So to find the equation of this line, when you find the equation of this line, you get a sigmoid function. This line is a sigmoid function, an S-shaped curve. And the equation for this curve is this. So when you compare this line, this equation and this equation, you can see the right hand side is same, on the left, only the left hand side is changed. So now if I try to plot this data, if I try and plot this information, right? It will make sense. Why? Because if I get these points, if I say at this line, what is the probability? 0.07. That means it is near to 0. What is the probability? A 35% probability, 85% probability at 40, and 50, it is almost 90, right? More than 95. So what I am saying that there is 95% chance of this value being yes or no. Whether the person will survive. Let's say if there is a Titanic data set which tells you if the person survived or if the person did not survive. So your output, what you want to predict is 1 or 0. So what you are trying to find out is the probability whether the person survived or not survived. Does that make sense? To a certain extent.
Yes, sir.
So let's look at some data. So if you remember, we had that prostate cancer data set. Remember that? Would have tried that. This is my prostate cancer data set. How does it look? I look at this. This is my diagnosis. I cannot use linear regression over here. Why? Because my diagnosis is or a M or a B. So let me just copy this data before I mess it up. My data is a M or a B. So copy this data in the end. Copy it here. M means malignant, so I'm going to keep it as 1. B means benign, so I'm going to keep this as 0. Okay. Now I need to check if there is any missing value over here. In this column, I know there is a missing value over here. So let's search for NA. I'm going to do condition formatting. I add a new rule equal to NA. Format this. Fill it. Okay. So I can see the NAs over here. You see the NAs? Do you see the NA? There are 5 values which are NA. One minute. Like I said, there are 5 values which are an NA over here. So what we need to do, there are 2 ways. Either I remove these rows. There are 5 rows over here. Either I remove those rows and continue, or what I do, first of all, I'll check what is the average value. The average value is 0.124597. Let me just note that down. 0.124597. Fractal dimension. For this column, the average is 0.064816. 4816. Right. So what I can do is very easily So select this Na and add these values over. I replace the Na with the average value of this particular column. In this case, in case of fractal dimension, again select this value. And add the average value. That is the mean. Right. Let's now in Excel, again in that same add-in, you have an option of logistic regression. In data analytics tool itself, there is an option of logistic regression. So when you go to regression over here, there is an option of logistic and probabilistic regression. I click on this. The difference being the last column should be the column which has a value of 1 or 0, or it should be binary. It should be binary. So let's select this. I will fill it. I make this new and I press enter. And I get an Excel like this. So if you see, the first columns are same as what is there in your data. This data is mostly sorted. If I am not mistaken, this is sorted because here it does not start with 23, it starts with 9. This data is sorted over there. This is telling me success or failure, the observation. What is important is this prediction. Okay, this prediction is telling me what is the predicted value for you compared to what was the actual value. So here, this success or failure is this particular column that you have is the diagnosis result. And what I'm getting over here in this P observation, in this P prediction, okay, 0.98, it converts that into 1. This, and over here in this percentage correction column, it tells me what is the correctness of this value. And if you go to the bottom, it will tell you 88% values are correct. That is the accuracy of this model, 88%. At the bottom, you'll also see these points. That is what is the coefficient, what is the p-value for each of them. So you can see symmetry does not have that much of a weightage, nor does radius, is what it's telling me at this point. Okay, because the p-value is not so much near it. But still, I'm getting a decent output. There is something called as a confusion matrix. Let me see if I have that. What happens in this is a classification problem, by the way. In terms of what you are predicting is you are predicting this is a problem of classification. You might have seen that earlier. So here I want to find out whether a customer will leave you or not. Churn means the customer will leave you, yes or no. There can be some prediction which is correct, some prediction which is incorrect. The way to look at it, this is my actual data which tell me that the customer will churn. This green color indicates the customer will not churn, rather. This red oranges color will indicate that the customer will churn. The output of this logistic regression is giving me a value like this. It is giving me some true positives, some true negatives. So it is telling me that it is predicting this value correctly. Yes, it will not churn. And over here also, it will not churn. The customer has not churned. Here, it is telling me that the customer will churn, but in actual, the customer has not churned. So this is a false positive. So just imagine if a patient does not have prostate cancer and you tell them that there is high probability you have cancer. The chance, I mean the mindset of the person will change so much, right? It's going to impact him so much. So this confusion matrix gives you that view in terms of how good the model is, and you find out true positive, true negative. You find out false positive, false negative. So what is correct? The person was going to churn. Yes, you predicted that correctly. This is actual. This is predicted. In that same way, the person did not churn. You also predicted that correctly. That is true negative. When you say that actually it did not churn, but you predicted that it churned, it is false positive. And in the same way, over here, when it's false positive, in actual it churned, but you predicted it did not churn. The person did not churn. So that is your false negative. So this tells you your sensitivity, okay, and then your specificity. Overall, this diagonal value is giving you the accuracy of the model. So in that same way, you get the accuracy of the model over here. So you see this accuracy, you get that value over here. You see, when we chose that logistic regression model, there was a parameter over there. There is a parameter. This cutoff 50%. Okay, that same cutoff is over here. What it indicates, now if I change this cutoff to 0, that means any value above 0 is going to be considered as success. If I make this as 1, any value below 1 is going to be considered failure, which is why you take 50%, the probability as 50%. Anything above 50% you consider as 1. Anything below 50% you consider as 0. I can change this probability value. I can make this to 0.25 as well, and it will give me a different view itself. But we choose to make it 50. We consider it as 50%. Make sense? Yes. The main aspect in this Excel that you get is this confusion matrix. Hello.
So with the help of cutoff, we can improve the trustworthiness um, of the metrics.
Yeah, you can make this 60% also, depending on what you want. But ideally, it's supposed to be taken as 50, because that is where you will not see much of a difference. It's normal, right? Above 50%, आपका percentage passing भी 40% या 50% होता है, right? In an exam. But you can change this value. It depends on the situation. This value can be changed, but most of the times it is taken above 50% as 1, below 50% as 0. All right.
Yes.
This is what we did in, and again, you can reiterate based on this p-value. You can reiterate this model based on the p-values. What we are going to do now, we're going to try this in Python. Okay, we'll try this. This is the only thing we'll try it for today, because there aren't many people today, but I just wanted to explain that there are not many people. Let me open a new notebook. Java. So I need these 3 libraries, by the way. It is ready. Okay, now it is read it. So I've read the file. We can dot head. So I'm just viewing the data. The first step, like we did in Excel, we want to check whether there is a null value. At this up till now, we have not tried to handle any null value in Python. We're going to try and do that now. Here, when I type this command of is null and dot sum, I can see that compactness has 3 null values and fractal dimension has 2 null values. So if I just print pecan, and I search for the word nan, I can see this. I can see this value of nan, the 12th. Okay. If I want to just see that,
Sir, your Python screen is not visible.
anybody else not able to view it?
So to me, it is visible.
Let me try sharing. आपको दिख रहा है क्या? अभी दिख रहा है?
हाँ सर, अभी दिख रहा है. अभी मतलब यू हैव चेंज द स्क्रीन ऐसा दिख रहा है. वो जो एक्सेल का था वो चला गया.
हाँ, एक्सेल नहीं दिखा रहा हूँ मैं, जुपिटर दिखा रहा हूँ.
हाँ वही, अभी वो ब्लू कलर का स्क्रीन दिख रहा है.
ब्लू कलर का स्क्रीन.
हाँ
आपको मेरा ये दिख रहा है? ध्यानेश, कैन यू सी माय स्क्रीन?
Yes, sir. I can see.
आप एक बार लॉग ऑफ करके लॉगिन करोगे क्या?
हाँ सर वही.
वो स्काइप में होता है थोड़ा. So if I look at the 12th row, if I just look at the 12th row, I can easily see this value is NaN. And I need to fix this. I need to fix this value. So here we are going to be using another function of sklearn. Okay, we're going to be using another function of sklearn. And you can actually check this. I mean, I can show it to you in this way also. If you want to see it horizontally, because vertically, if you want to see it horizontally, you can see it in this format also, where you have all the columns and you can see that this compactness is NaN. So what we need to do, we need to fix it. So here I am going to use a function. I'm going to use another, like I said, simple imputer. Yes, I'm going to impute specific values in the data. And for that, I am using this. What it does, I am using this sklearn.impute from imputer. So if you want to again find out any information about this, I can again go over here to this particular class, to this particular website. I go to API. Imputer. Sklearn impute. Simple imputer. This is what I'm using. It is used for completing missing values. This is the function which is used for completing missing values. So if you look at this, the code is also given over here. Wherever it finds a missing value of nan, the strategy is mean. So here, if I have this value, okay, this value, you see this 4 is nan. It's going to add a value of, it's going to add an average value for this particular field. Okay, so if I look at it, that's what is done. It is adding a mean for that entire, and I'll show you how it works in our data set. Okay, I'll just show you how it works in our data set. It is searching for missing values. So this imputer, the first function is obviously I am using another variable impute, for which I am calling the simple imputer, which I will import from sklearn. The first parameter in this simple imputer is missing values. It is going to search for missing values, which is equal to nan. And if it finds the missing value, what should be the strategy? The strategy is imputing that value using mean. Make sense? This is what we did in Excel. This is what we did do in Excel. All right. We added this value 0.124559. That was the average 124597991, right? That was the average of this particular column. That is what it's going to do. So I'll show it to you for one, by the way. I know the column 0, 1, 2, 3, 4, 5, 6, 7. So let's try it only for the seventh column, by the way. Let's try it only for the seventh column. 8 hoga, 7 to 8. So it does like you have regressor.fit over here, you have imputer.fit, and what you provide is the column which you want to impute. Okay. And in the next line, if I just do this, right? If I just do this, it's going to impute the value, but it's not going to save it anywhere. It's just going to impute the value, but it will not save it anywhere. Which is why I have this line where I am allocating the same output over here. Okay, first this is just fitting that value, then I am using the transform function of imputer. Once I have done this, I am going to store that value and replace that value over here. Okay, when I do this and when I copy this, okay, sorry, my bad. Yeah. Now if I print this, you see 124598. Earlier it was nan. It has imputed this value of 124598. Make sense? What I need to change is the columns where the missing values are there. Okay, I chose only one column. I can actually choose more than one column. I gave only one column, but I know that fractal dimension also has a nan value. So now if I print this again, if I print this pcan is null again, I see fractal dimension still has a null value. So what I can do, I can literally 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. So I can go to the last column. Since the last column is not inclusive, I need to use 10 over here instead of 9. And when so it's going to search in all the columns. And when I do this, okay, I don't need to print this again. Now when I print this is sum dot null, you see for the fractal dimension also the null values are gone. You understood what I did? When we printed this value in the beginning, okay, when I first printed this function is null dot sum, for each of these columns it is telling me that there are 3 null values over here and 2 null values in fractal dimension. Make sense? That's the first thing we did to check if there are any missing values in the data. Right? Now I have my data. Now I need to structure this data in again X and Y. Okay, the logic remains same. What we did in linear regression, the logic remains same. What I need to do here is split this into 2 columns. Okay. For this, now again over here, this data, we will have to check how we do that. This ID does not make any sense. The diagnosis result is something we need to convert into a 1 and a 0. So we had once used categorical variables. I will show you another variance in terms of how you can convert that 1 and a 0. We'll be using something called as label encoder. We will try that as well. Okay, so that you have an idea. Okay, so first again we'll try this one and okay. Okay, so let's do y is equal to pcant. I always forget to write I log. I print y. So I get this column. Okay, I get this column. Now what we are going to use, we are going to use another function. We are going to use another library. It is called as label encoder of a scalar. So I'm going to use label encoder. And again, if I want to search for label encoder, I can go over here. Go to API. I search for label encoder. Encode target labels with values between 0 and 1. 0 and n classes, whatever it is. Okay, that is what it does. So I'm going to use this label encoder. Okay, over here. So in the same way, I import this library. The steps are almost similar. You import the library, you assign a variable, LE as label encoder. What we were doing earlier, we were importing linear regression. We were assigning a variable is equal to linear regression, right? This is what we did. Then we did linear regression dot fit. In some cases, we also used above, which we saw. Yeah, we saw fit and then we saw transform. Okay. So here you either you say, then you have to transform if required. Okay. So here we are going to use label encoder. And for that label encoder, we are going to transform that value of y. I have chosen y. I'm going to transform that value of y. And I get an array of 1 and 0. This is what is required. Right? So if you check in the Excel sheet, the first column is 1, then 0, 1, 1, 1. Right? Malignant M, B, M, M, M. This is what I'm getting over here. M, B, M, M, M. So I've converted that value into a 1 and a 0. Okay. Now, what I'm going to do is, so I have my right hand side also ready. I have my y variable also ready. I just have to get my x, which is from this radius till this fractal dimension. So what do? Because I don't have any missing values as of now. So my x is equal to, let's see, can colon block, forget the I. Yeah, so I have x also in this. I'm just going to write dot values because I want it as an array. All right, so I get it as an array. It just shows it in a weird way, but That's how it is. I don't need to print it. Okay, so I have my X and my Y. So now let's go back to this site and search for logistic regression. When you see logistic regression, do you see it? Logistic regression. All right. So linear model dot logistic regression. So what it means, I need to import logistic regression from sklearn or linear model, you know. Okay. Linear underscore model. Okay. How is it that way? Yep. Linear underscore model. Linear underscore model. Import logistic. I import this package. Now, instead of a regressor, we have a classifier. Because this is a classification problem, I'm just going to call it classifier is equal to, like we did linear regression, we're going to do logistic regression. Okay, I create a classifier logistic regression. And again, I need to, what do you think I should do now? Classifier dot. Any idea? Anybody, any idea? Teen bandhu.
No, sir.
Like we did in linear regression, we did regressor dot fit. Here also you need to do classifier dot fit x comma y. Make sense? जो आपने Excel में किया यहाँ पे, what were you passing? You were passing x and y, right? So in the same way, the parameter will not change over here. Here also I'm going to use x and y, and it's telling me log this. Now what I need to do is I need to create a confusion matrix. Okay, like I had over here in this Excel sheet, I created a confusion matrix, right? For this, right? I created a confusion matrix. I want to create a confusion matrix in a similar way over here. So for that, again, there is a separate package. So if I search for confusion matrix, it is from matrix. Okay. Confusion matrix is in matrix. So if I look at this, if I go over here, tells me the accuracy of here. Yeah. So from sklearn.matrix, import confusion matrix. That is what I'm supposed to write over there. I'm supposed to import this package, import another from sklearn dot matrix, import confusion matrix. Spelling चाहिए ना? Confusion underscore matrix. Okay, I imported this value. And if you see confusion matrix, why print this? So I simply have to do it this way. I mean, I can assign it to something also, but I'm going to write CM is equal to confusion matrix. I did this fit, but I also need to do, by the way, I forgot to do one thing. I also need to predict the value. Okay, so I'll do y pred equal to classifier dot predict. And I'm going to do x. So like I said, I'm not splitting the data, but you can split the data. That is a better way of doing it. There is a better way of looking at it. Okay, in this confusion matrix now I pass y and y predicted. If I print CM, I get this 56, 29, 9, 6. Okay, ये उल्टा है. The diagonal is opposite. So you see there is slight variance over here, but overall the model is giving you a similar output. 29, 56, 9, 6. It's giving me something similar to what I have in Excel. Make sense? And you can easily print this. You can easily print this using another. So we had seen this C-bond long back when we had printed a box chart. In C-bond, there is also a heat map where I can pass this value of CM. It will give me the output. You notice 56, 29, 9, 6. So you can notice over 1, 1, 0, 0. That is what it's telling me. So this is my true positive. This is my true negative in that sense. Got it? So this is what I wanted to explain. But we will repeat this a bit next time because it's going to be a little complicated since you saw it for the first time. If you want to see the percentages, all right. So if you want to see the percentages, what I have done, instead of passing CM, I have passed CM upon NP dot sum of CM. Right. That gives me the percentages. And this is the color in terms of blues. It is going to give me the blue color. It is going to give me all colors as blue. So CM upon NP dot CM, NP dot sum. Okay. So numpy sum of those values. Got it? Practically, it's the same thing because these are only 100 values are 100 total. So which is why the percentage is shown as this. Make sense, guys? This is what is logistic regression and how you can do it in Python and Excel, by the way. You can divide it with literally the value which you have 29 plus 56 upon 100. You can do. Right? 2, 2. Alrighty. So you see 1, 1 is 56. 0, 0 is 29. So I can literally do plus this divided by dot sum of CM. 0.85. Got it? I think the score will also give me the same value if I'm not mistaken. Let me just try what the score gives me. In this case, we had done classifier dot score. Go ahead. 0.85. This is the accuracy. If I'm not mistaken, this is the accuracy. I don't think this is R square. I was confused actually earlier, but I will confirm this. Okay, guys, understood? You got an idea? So we have seen multiple linear, we have seen simple linear regression, multiple linear regression, and we have seen logistic regression now. All right. There I have placed additional data sets over here in terms of our logistic regressions. I would suggest you try them for immunotherapy, prostate cancer, breast cancer, and Titanic. So try them, you will get an idea how things work. Unless you don't try, you will not get an idea. Okay. Alrighty, कोई विशेष टिप्पणी मित्रों? If not, we'll call it a day. Happy Ganesh Chaturthi to all of you.
Happy Ganesh Chaturthi to you as well.
धन्यवाद मित्रों. Thank you so much.